Today's video is going to go over how to do stoichiometry, limiting reactants using ice tables. Before we get started, let's kind of define what a limiting reactant is. Simply put, a limiting reactant is going to be a reactant that stops your reaction first. Once you run out of one of them, the reaction can no longer go forward. Similar to if you're driving your car and you run out of gas, you can no longer go any further. Limiting reactant is the same thing. Must always remember that if we are given a mass, we must convert it to moles first in order to put it in our ice table. And as we're going through, we cannot just simply assume that the reaction after we do our mass to moles conversion with the smaller number of moles is our limiting reactant. And in fact, it might not be. And there is an example here which shows that in fact that does happen. So let's go ahead and jump right into it. A 50-gram sample of calcium chloride and a 75-gram sample of sodium phosphate are reacted together. We need to find three things. We need to determine what the limiting and excess reagents are. We must figure out how much of the excess reagent remains, and we need to know how much calcium phosphate and sodium chloride will be produced in this reaction. I've already calculated out the molar masses for you. Just to make it simple, make sure that you write them down because we will use them for this example and the next. So the first thing that we need to do is to convert our masses that we're given to moles. So let's take a look at the two that we're given. So we set up our conversions for calcium chloride and sodium phosphate. So if we calculate out calcium chloride, we will get that is 0.4505 moles. And if we do the same thing for sodium phosphate, we will get that is 0.4575 moles. Well, now, similar to when we worked our ice tables before, we're going to put these two values in our ice table. But unlike last time where we had one that we did not know, in this case we know our starting points for both. So we're going to put both of these in the table. If you look in that box under change, you see that it's kind of changed itself slightly. In this, before we had only 2 boxes under change, and now we have 4. So what we're going to do is we have to look at each one of these individually to see how they reacted with each other. So just like we did before, let's start with calcium chloride. We're going to take this number, multiply it by 2, and then take that answer and divide it by 3. And that's going to give us the value for this box right here. Now to fill in this box, all we're going to do is simply bring this number on down. So 0.4505. And we're going to do the exact same thing, except we're going to fill in the second set of change boxes. So to fill our second set of change boxes, we're going to take this number, we're going to now multiply it by 3, and then divide it by 2. And that will give us this box right here. To fill in our other change box, we're just going to bring this number right on down. At this point, visually, this is kind of chaotic. So what I'm going to do is let's take a look at the calcium chloride line individually, and let's look at the sodium phosphate line individually. So same thing like we did before in the other video is we're just going to take our values and subtract and get our answer. So if I subtract 0.4505 from itself, I'm going to get 0 moles here at the bottom. And if I do the exact same thing for the other column, I'm going to get 0.1572. So we've just evaluated calcium chloride. Now let's look at sodium phosphate. And we're going to do the exact same thing that we did on the other side. When we subtract the first column from each other, we're going to get a negative 0.2358 moles. And in the second column, because both of the digits are the same, we're going to get 0 moles. So what we're looking for between this one and this one is we're looking for which one does not give us negative numbers. If we take a look at this one right here, this calcium chloride line gave us negative numbers. So since this one gave us negative numbers, this one does not work. We cannot use this information. So we need to go back and use the other one. Everything that we evaluate will be based upon the data from this one right here. So the first question asked us to determine which one of these is going to be our limiting reagent and which one is going to be our excess reagent. If we look at calcium chloride, since we run out of it, this one is going to be the one that's limiting. And in the column next to it, because it's left over, it's going to be excess. Part B asks us to determine how much of the excess reagent is left over. Well, if we look in the box for excess reagent, this right here is what's left over. If you want to, on your own time, you can convert it to grams, but for simplicity's sake, we're going to say that right there is the amount that's left over. So we've got part A and part B done. Now the next thing it asks us to do is to calculate out the amounts of each of our products that we have. You are going to use the information in your column for your limiting reagent in order to determine how much calcium phosphate and sodium chloride is going to be used. So just like before, we're going to start off in these two columns with none of this and none of this because we did not have any from the start. We had not mixed them together yet, so we don't have any. And then we're going to work this just like we would a regular stoichiometry problem. So I'm going to start here at my calcium chloride. I'm going to multiply that by 1, and I'm going to then take that number and divide it by 3. And when I do that, I'm going to get this value. And when I do my calculation for the amount that we produced, I get 46.59. And I'm going to do the exact same thing with the sodium chloride. I'm going to take 0.4505, multiply it by the coefficient 6, and divide it by the coefficient 3. Or you could just take 4.05 and multiply it by 2 because 6 divided by 3 will give you 2. Just a quick alternate way to do it. And then when we calculate it out, we get 52.65 grams of sodium chloride that will be produced from this chemical reaction. So let's take a look at another example. And we're going to use the same chemical reaction that we did here, except we're just going to change up the numbers a little bit. In this scenario, we're given 25 grams of calcium chloride with 20 grams of sodium phosphate. And we're going to be looking for the same things that we were looking for before. We're going to look for our limiting and excess reagents. we're going to determine how much of the excess reagent is going to be left over, and theoretically how much of each product will be produced from this chemical reaction. So, same thing as we did before, the first thing that we need to do is convert those grams to moles. And once we do our calculations, this is what we get. So we're going to do the same thing that we did before, and we're going to take these two values and we're going to plug them into our ice table, or our modified ice table. And we're going to evaluate our numbers the exact same way that we did before. So let's take this 0.2273 and bring it on down first because it's the easier one to work with, and then we're going to do our calculation. We're going to take this value, multiply it by 2, and then divide it by 3. And that number is going to go again right here in this box. And then we're going to do the exact same thing for the other one. So we're going to bring this 0.1220 moles down. And then we're going to evaluate it the same way we did the other one, except we're going to go the opposite way. Multiply by 3, divide by 2. That answer goes down here in this box. To make this easier to read, we're going to clean this up a little bit, and we're going to evaluate only one at a time to make it a little bit easier. So let's start with calcium chloride. When we subtract calcium chloride from itself, we're going to get 0 moles of calcium chloride. And then we're going to do the same thing for the other one. I'm sorry, that's incorrect. Hold on. I had a little brain lapse there for a second. And then we're going to do the same thing for the other one, and that value is going to give us a negative 0.0295 moles. So I'm hoping that you guys are seeing what I'm seeing already. Well, let's go ahead and do the next one. And we'll go through the same process. Subtract those first two values from each other, and this is what we're going to get. And then we're going to do the same thing with the sodium phosphate column. We're going to subtract it from itself, and we're going to get 0 moles that'll be left over. Again, we evaluate them against each other. We'll see that this one right here for the calcium chloride gives us a negative value. So since we have a negative value for calcium chloride, we cannot use it. So this one right here does not work. And we're going to use this one right here. So everything will be based around the sodium phosphate. But first, before we do that, let's identify limiting and excess reagents. So again, as we stated before, the one that gives you a 0 is going to be your limiting reagent. The one that gives you stuff left over is going to be your excess reagent. And we can clearly see from this one what our limiting and excess reagents are. This is the amount of the excess reagent left over. Again, it depends upon what you're asked. If you're asked to convert it back into grams, make sure you do that. For the sake of time here, we are not going to convert it back to grams, but you could do that on your own if you wanted to. We use the column for our limiting reagent in order to determine the remainder of our calculations. So we'll use the 0.1220 moles to calculate out calcium phosphate and sodium chloride. So you should be able to do this on your own by now, because at this point it's just regular stoichiometry. So again, focus on this column and then do the rest of the calculations. Pause the video, and then this will be a quick way for you to check yourself and make sure that you're correct. Alright, and we produce calcium phosphate of 18.92 grams and 21.39 grams of sodium chloride. These next two problems are going to be practice problems for you to try. And I'll work each part out individually and give you the answers. I've already calculated out the molar masses of each one of the compounds that you're going to be using in this problem. So at this point, you can pause the video now to calculate out your molar mass or your moles of compound. All right, this is what you should have got. Now let's take a look at our ice table. Go ahead, pause the video now, fill in just the first part, and then we'll work the calculations after that for the products and everything else, and determine which one is limiting in excess. After we evaluate, if we look here, we can kind of see which one is going to produce negative values, and it's going to be this one here at the bottom. So we're going to not use it, and we're going to use this one right here, which goes with the aluminum iodide. So let's clean this up a little bit to make this a little bit easier to work with. And now all you do is your subtraction and get your values. Go ahead and finish it up now and determine how much of your excess reagent is left over. Determine which one is your limiting reagent and determine the amounts of products that you are going to produce. Pause the video. Alright, take a look at your table. This is what you should have gotten, or something very similar or close to it. Very straightforward. Let's take a look at our last sample problem and see how you do with that one. So same thing as the other three that we've worked so far. You're looking for the limiting and excess reagents, determine how much of the excess reagent remains, and theoretically how much of each of your products should be produced. So at this point, pause the video, make sure that you got your moles calculated out correctly. This is what you should have calculated for your moles, or something very, very close to these values. Let's go to our ice table and let's fill it out. I guess also fill out your ice table at the same time. I didn't realize that it was on the next slide. So pause the video again, fill out your ice table, and then we'll go over what you should have. Alright, so this is your ice table. You can evaluate it at this point. If you need to break it down individually, do that. Take the time out to do it until you get good at it. When we look at this, we can tell that the first one is going to give us negative values because 0.552 is smaller than 0.737, so this one will not work. And we are going to use the one here at the bottom. Let's clean it up a little bit and let's go to the next slide. And now it's just basic math at this point. Go ahead, finish filling out your ice table, take a look at your answers, and that will be it. And here is your completed ice table. Should have gotten 49.1 grams of aluminum chloride and 251 grams of mercury 2 iodide. If you have any questions, comments, concerns, leave them in the comments.